Problem 33 reads, Kristen invested $2,000 into an account with 5% interest rate. It asks you in part A to write an equation that represents the amount of money in the account over time. This is going to be an exponential growth problem. So it's going to be y equals our initial amount, which was 2,000, times 1 plus the rate, which was 5%, written as a decimal, which is 0.05, to the t power, because it's over time. It just wants our equation. For part 2, it asks how much money will she have after 15 years. I'll take y equals 2,000 times 1.05, because I added that up there, and it'll be to the 15th power, because that's how many years. I then will plug this all into my calculator to get the amount after 15 years to be 4,157.86. Problem 34 reads, Mr. S has a stuffed cat collection of 23,456 stuffed cats. His collection of stuffed cats decreases by 24% each year. So this is going to be an exponential decay, and we have our formula for that from our notes. So writing an equation that represents this amount would be y equals our initial amount again, 23,456, times 1 minus. On the decay, you take 1, which is the whole, which is 100%, written as a decimal, 1 minus 24%, written as a decimal, which is 0.24, up to the t power. We're writing it in terms of the time. Then part B asks, how many stuffed cats will he have 13 years from now? So y equals 23,456 times 1 minus 0.24 to the 13th power. I'll again type all of this into my calculator to get 661 cats. Also, with these problems, I always think about if the answer would make sense. So if it decreases by 24% each year and it's 13 years, the answer of 661 cats would make sense. If my number would be larger than 23,456, I would know that that would not be an accurate answer.